Today I am going to start the section formula which is required for exercise 7.2, of course in coordinate geometry. See children, before this, that is in exercise 7.1, we derived the distance formula and we worked on the distance formula. What was the meaning of distance formula? It gives the distance between any two particular point. Any distance formula is used to find the distance between any two particular point. But now we have to work on section formula. So first we should know what is the meaning of section formula. What is the application of the section formula? As distance formula, this is the distance between any two points in a coordinate system. Similarly, we should know regarding the section formula. What value does the section formula gives us in a coordinate system? So see children, as the name suggests section formula, so section formula will give the, listen carefully, section formula will give the coordinate of a particular point which divides the given line segment in two different parts. I again repeat. What does the section formula gives us? It gives the coordinate of a particular point which divides the given line segment in two different parts. See children, my word is given line segment. That means two end point are fixed over here. So their coordinate must be known to us. And then third point will divide the, suppose I take the line segment AB. So the end point are A and B. Segment means end point are fixed like A and B. And the third point P divides the AB in different parts, which is called the ratio, different ratio. So suppose children, I have taken a line segment AB in a coordinate system of X and Y. Clear? So similarly as we did in the distance formula. So suppose what must be the coordinate of it? First you will come towards the x-axis. So I have taken as a x1, and then you will go towards the y-axis. So I have taken point A as a x1, y1, and point B as a x2, y2. You are knowing it very well. Whenever we fix a coordinate of any point, first we take the x coordinate point and then we take the y coordinate. Clear children? So I have taken that A is x1, y1 and B is x2, y2. These are the end point of the given line segment AB in this first quadrant of the coordinate system. Clear? Now, what is the role of P? The point P, assume its coordinates. Since AB I have taken as a x1, y1, x2, y2. So P you take as a x and y. Of course, when you come towards the x-axis, you take as a x, and y-axis you take as a y. So the point P, let its coordinate be x, y, divides the line segment AB. P will divide the line segment AB in two different parts. Take the ratio, or you can say two different ratios, say M1 and M2, or M1 raised to M2. So P divides the AB into first part AP is M1 and second part PB is M2. Right? So what actually we have to find here? We have to find the coordinate of Pxy. That means value of coordinate of P as an x coordinate and y coordinate value we have to find. Pxy value we have to derive from this section formula, and that will be the final formula which AB, which is divided by the third point P in different ratio. Right, children? So that is the later part, what they will provide us and what we have to find. That is the later part. Right now we have to concentrate how to derive the section formula, that is the value of the point P x y, which divides the line segment AB in different ratio M1 and M2. Okay. Okay. So see, whatever I just explained, I have written over here. We consider any 2 points A as a x1 y1 and B as a x2 y2, and assume the third point P as a xy divides the line segment AB internally in the ratio M1 raised to M2. Clear, children? That only I have written, whatever I have explained it right now. Okay? So PA upon PB, its ratio will be what? M1 raised to M2, that is PA upon PB is equal to M1 upon M2. Since P divides AB, so P divides means what? Two parts. So PA upon PB, its ratio is M1 M2, so M1 upon M2. I hope this much clear to you, right? Take a line segment AB, whose end point A as a x1 y1, B as a x2 y2, and third point P xy, which divides the AB in different ratio as a M1 and M2. So PA upon PB will equal to M1 upon M2. Clear? Okay. Should I proceed further? Okay. Now, what you will do, same thing as we did in the distance formula, you will you will draw the perpendicular from the particular point to the x-axis. Same one as we did in distance formula. So draw AR perpendicular to x-axis, PS perpendicular to x-axis, and BT perpendicular to x-axis. So same thing I have written over here together. Okay. Now draw AR, PS and BT perpendicular to the x-axis. Whatever I am saying, that only I wrote here. Right? And then draw AQ and PC parallel to x-axis, or another word you can say, draw AQ perpendicular to PS and PC perpendicular to BT. So when you draw the perpendicular line, it will be automatically parallel to the x-axis, or when you draw the parallel line AQ parallel to x-axis and PC parallel to x-axis, then by the corresponding angle it will be perpendicular. Right? Automatically it will be, because the parallel lines, the distance between the two parallel lines are equal. Right? So 90-degree angle you will get. So any wording you can use over here. Okay, children. So this much clear. Perpendicular we don't. So we are getting, see here, as we got one right triangle in the distance formula, and we have applied the Pythagoras theorem to find the hypotenuse AB. Right? Similarly here we are getting the two right triangle, because here 3 points are there. But in distance formula there were 2 points. So we got one right angle. Here 3 points are there. So we are getting the 2 right angle. It's okay. Right? Now, so what do? We show that these two right triangle, that is the PAQ and BPC, are similar to each other. How they will be similar? By angle-angle criteria. Why they will similar in angle-angle criteria? because here this angle is 90 degree and one angle you will get the corresponding angle, because the perpendiculars are there and this will be the transversal line, right? So you will get the corresponding angle, and corresponding angles are always equal. So you have to not mention this, okay? Directly you have to write by angle criteria, these both the right triangle will be similar to each other, right children? Now someone can ask you why you are making these two triangles similar. So the answer will be because we want the since point P divides the AB in different ratio, right? So we want the shear ratio of the sides, and how we get the ratio of side? When the triangle will be similar. You are knowing, if the triangles are similar, then all the ratio of all the three pair of sides are in proportion. Any ratio of sides are equal. So this is the only way to bring the all three ratio of sides equal. You just make the triangle similar. So by angle criteria, the triangle will be similar. So that I written angle criteria. Triangle PAQ is similar to triangle BPC. And since the triangles are similar, so the corresponding ratio of side will be equal. So take the corresponding pair. See, I have taken first two PA, so here first two will be BP. So PA upon BP will equal to, then last two AQ, so here last two are PC. AQ upon PC, right? AQ upon PC, right children? Then first and third pair, PQ, here first and third pair is BC. So PQ upon BC children, right? So all the three ratio of sides are equal. So now see children, PA upon BP, this ratio is known. PA upon BP is M1 upon M2. So this we will replace as a M1 upon M2. But these values, AQ, PC, PQ, BC, these values you have to find from the coordinate system. So one by one you see. First is AQ. Now see the position in the figure. Where is AQ? This is the AQ children. See, this is the AQ. So this AQ will equal to what? RS. AQ will equal to RS. So you find the RS. So how will you find RS? This OS minus OR children, right? So I written here OS minus OR. OS minus OR. And OS, what is its x coordinate? We have taken P as a x. That means this point denotes the x. So x minus OR. What is the x coordinate we assumed here for it? X1. So x minus x1. So this is children x, and this is the x1. So this will be what? X minus x1. Right? So this we got the value of AQ, which is equal to RS as the OS minus OR, that is x minus x. Clear? Now, second is PC. See the position of PC. This is the PC. So PC will equal to what children here? PC will equal to ST. So find the ST. How would you find the ST children? OT. O to T. What? You will go O to T minus O to S. So what is the OT? X coordinate we have taken x2. So this distance will be x2. And OS, S is x. So this will be what? x2 minus x. x2 minus x. So see, OT minus OS, that is x2 minus x. Right children? Now come to the perpendicular heights, that is on y-axis. PQ, where is children PQ? This is PQ. So see, now I will not draw any more line because the figure will be then that will be very dirty figure, it becomes very dirty. Okay, so just I will tell you like this only. Now see the PQ, this is PQ. How do you find the PQ children? PS minus QS, right? PQ, PS minus QS, right? So PS What is the coordinate for y? Now you will see the y coordinate. For perpendicular distance, you will take the y coordinate, and for horizontal, you will take the x axis. So this coordinate is what? Y, and this q. So this q denotes to the whatever coordinate you will get for a, same coordinate you will get for y1, because same line is coming here, perpendicular line to the y axis. So this will be y minus y1. So this y minus y1. Right, children? Then BC. This BC will be what? BT minus CT. BT minus CT. So BT, that is y2, and CTC coordinate, as it indicates, P coordinate, that is the y1. So y2 minus, sorry, y coordinate, it is not y1, it is y. So y2 minus y. Clear? Now, put these values in the ratio, given ratio, PA upon PB equal to AQ upon PC equal to PQ upon BC, children. So this PA upon PB is what? M1 upon M2, AQ upon PC, AQ x minus x1, and the PC x2 minus x. Then PQ upon BC, so PQ write y minus y1 upon BC, that is y2 minus y. So here all the three ratios are equal. Now what you will do? This x coordinate difference equal to y coordinate difference, which is equal to the ratio m1 and m2. So each ratio you will show equal to m1 upon m2, and you will do the cross multiplication, and you will get the value of x and y. Right, children? So one by one we look at here. You will show here m1 upon m2, right, children, is equal to x minus x1 upon x2 minus x, and here m1 upon m2, children, is equal to y minus y1 upon y2 minus y. Right, children? Now you will do the cross multiplication. So see, m1 x2, okay, what did we get here? m1 x2, one by one I will do. m1 x2 minus m1 x minus m1 x, children, right, is equal to, come to next, m2 x minus m2 x1 children, right? m1 x2 minus m1 x equal to m2x minus m2 x, right? Simply we cross multiply over here, right? Now what do? We collect the x variable on one side, and we will show the value equal to the x, right? So now see, x variable, see this is x and this is x, right? So see, m1 x2, this take on this side, so this becomes plus m2 x1, children, right, equal to, now see here, m2 x, and this x you take on that side, so minus go transpose to the right, it becomes m1 x, children. Clear? This will be as it is, m1 x2 plus m2 x1 upon, here x you can take common, so what you will get, children? m1 plus m2 into x, right? So x coefficient is what? m1 plus m2, so divide by this, so you will get, children, x equal to m1 x2 plus m2 x1 upon m1 plus m2. So this we got, children, x coordinate of the point P. P x coordinate value we got m1 x2 plus m2 x1 upon m1 plus m. In the same pattern, you will get the value of y coordinate. Let's work on y coordinate, second part. This is for x. Now second part, see, m1 y2, cross multiplication, m1 y2 children minus m1 y1 minus m1 y1 children, then m2y minus m2y1 m2y1, right children? Now same work, see m1 y2 m1 y2, okay, then take this minus m2 y1 on this side, so plus m2 y1, and then m2y, take this minus m1y, it must be y, m1y, not y1, right? So this will be m1y, right children? Now this write as it is m1y2 plus m2y1 equal to m1 plus m2, m1 plus m2 into y. Y we have taken out. So y coordinate we got children here in the same pattern, m1 y2 plus m2 y1 upon m1 plus m2. This is the calculation, right children? So we got the coordinate of point P, xy value, x as a m1 x2 plus m2 x1 upon m1 plus m2, and y coordinate as a m1 y2 plus m2 y1 upon m1 plus m2. So this is the section formula which gives the coordinate of point P as a x and y, which divides the given line segment AB in different ratio, say m1 and m2. Right children? So I hope you understood, and for more convenient you have to practice it again and again. So this we got section formula. Now there are the few convenient way, means this section formula we can convert in two more form, right? See, if x1 y1 given, x2 y2 given, pxy, you have to find on the ratio m1 m2, definitely you will apply directly this form. But suppose ratio is not given and ratio you have to find, so please don't assume the ratio as a x1 m1 and m2, then you assume the ratio as a k raised to 1. So see children, I will give you the modification, two more modification for this. Okay, so I am going to play on this side LHS part. Okay children, because few modification I have to give which will be easier to work you for the different type of the questions, right children? So on this side I will just write the modification of this formula, right children? All three formula I will write together on this part. Okay children? So of course I am going to claim this complete, otherwise you will get confused in so crowd manner. So to avoid that, I'll write the formula again. See children, number 1, suppose you have to find pxy, again I am writing, its coordinate will be m1 x2 plus m2 x1 upon m1 plus m2 and m1 y2 plus m2y1 upon m1 plus m2. This is the main formula. This formula can be modified for the different type of questions. Suppose if you have to find the ratio is not given, m1, m2 value is not given, right? So, to find, in short I write, ratio, assume ratio as k raised to 1. Don't assume m1 raised to m2, otherwise your calculation becomes complicated. So if you take the ratio as a k raised to 1, so this same formula, see, this becomes like this. m1 replaced by k, so it becomes kx2, and m2 replaced by 1, so it becomes x1 upon k plus 1. Instead of m1 plus m2, k plus 1. Right, children? Similarly, for the y, ky2 plus y1 upon k plus 1. So, in a single step, you will get the value of k and you will get the ratio in a very simpler manner. One more modification. If the ratio is 1 raised to 1, m1 m2 value is 1 raised to 1. So see, same standard formula can be modified in simpler manner. See, m1 m2 replaced by what? 1 and 1. So simply it becomes what? x1 plus x2 upon 1 plus 1 2, and y1 plus y2 plus y2 upon 1 plus 1 2. Right? So these are the two modifications for the type of the question if changed. If they are asking the coordinate value, then it's okay, simply you put the standard formula. If they are all the coordinates are given, if they are asking the ratio, so please assume the ratio as a k raised to 1, don't assume m1 raised to m2, otherwise you will be suffered, right? So the same formula modified again. For k raised to 1, you will use this formula to find the ratio. And if p is given midpoint of AB, that means ratio is 1 raised to 1, or gives p bisect the AB, so the ratio becomes 1 raised to 1. So no need to write this standard formula. Simply you write for the midpoint section formula as a x1 plus x2 upon 2, y1 plus y2 upon 2, which gives the value of coordinate p. Right, children? Okay, thank you, children. Revise this once, twice, thrice, so the concept will be more clear to you. Okay?